Hello, dear students. In the previous lecture, we have started our oxygen family and we have completed our physical properties. And then chemical properties we have started, and out of that also we have completed the oxidation state first. Okay. Second thing, what kind of hydrides they are forming, particularly these elements. Okay, form H2E kind hydrides. Okay, we discussed about the acidic character of them and reducing property, that how the reducing property varies. So down the group, reducing property is increasing. We know that. Okay, so these two chemical property we have already done. So now the next property is regarding the oxides, or you can say reaction with oxygen. So if E represent the element of the 16th group, so they all form oxides of EO2 and EO3 type. Two type of oxides are mostly formed by these elements, particularly, which you know very well that this have +4 oxidation state and this one have +6 oxidation state. So now if we talk about the oxides, the physical state, so ozone and sulfur dioxides is particularly gaseous, while further if you move, selenium oxides is a liquid, and tellurium, if you go for it is a solid particle. Okay. So now what we need to tell particularly, that yes, what kind of oxides they are forming. Then we have to discuss about the stability. So you know that stability of EO3 type oxides goes on decreasing down the group. Why we know that higher oxidation state, that is +6 oxidation state, is not stable in the lower group due to inert pair effect. However, I have defined you inert pair effect a lot of time, but still I am considering it again. That you know that they all have configuration in valence shell is NS-NP. Whole P block follow this configuration. Okay, particularly for 16th group is NS2-NP4. But you know that as we move down the group, mean to say, if we reach to the polonium, tellurium, at that time the energy gap between this NS2 and NP4 has become larger, while in case of oxygen, sulfur and tellurium, the energy gap is selenium, the energy gap between these two cells are not much. But in case of the lower elements like selenium and tellurium particularly, the energy gaps have become much greater. So that's why they will feel inert here. So they will able to form only +4 oxidation state rather than +6. So that's why we are saying that EO3 type of oxides stability goes on decreasing. Mean to say the lower element is only forming the EO2 type kind oxides. Now the next thing which you need to tell in the oxides is about the sulfur dioxides and tellurium oxides. A exception question arises there. So first I tell you the exception question is that sulfur dioxide can behave reducing as well as oxidizing. Okay, while tellurium oxide can only behave as oxidizing. Or this question can be in such manner that sulfur oxide is behaving reducing while tellurium oxide is behaving oxidizing. Why? Because they air exists in +4 oxidation, we know that. So this will, sulfur dioxide is able to go to +2 as well as +6 oxidation. So that's why it can behave both ways, reducing as well as oxidizing. But tellurium oxides can only goes from +4 to +2. Tellurium oxide is not capable to show +6 due to inert pair effect. So that's why tellurium oxides can behave as only as oxidizing oxides particularly, while sulfur dioxide can behave both. Okay. Now if you talk about the character, so you know that non-metal oxides are acidic in nature. So all oxides, well EO2 type or EO3 type, all are acidic in nature. And you know that EO3 type is acidic character is greater than EO2, because in higher oxidation state acidic character you will find is greater, okay, over particular oxides of the same element. Now this is all about the oxides that I'm summarizing you. This is an exception question we have discussed here. Inert pair effect also you don't need to tell, it will ask separately. What you have to summarize in the oxides that yes, they can form EO2 and EO3 type of oxides. Okay, then you will tell that that lower element group, in lower element EO3 type stability goes on decreasing. Then you have to discuss about the acidic character, that yes, acidic character down the group is always goes on decreasing. As the non-metallic character increase, acidic character increase. So you know that non-metallic character down the group is decreasing, that's why acidic character is decreasing. But if you are comparing the oxides of the same element in higher oxidation state, the acidic character is greater. Okay, so that you must have to tell in the oxides of the particularly our 16th group. Now the next one is halides. So that's what kind of halides, or you can say reaction with halogen. So if E represent the element of the 16th group and X represent the halogen, that is fluorine, chlorine, bromine and iodine, you know very well. So they all element first thing have from these kinds of halides particularly. Okay, now among hexahalides, only hexafluorides are stable. Mean to say hexafluorides only are stable, and that is also gaseous in nature. While if you go for hexachloride, bromide, iodide, that is not possible. Okay, so hexafluorides are only the structure. Here the hybridization is sp3d2, and the structure, if you talk about the hexafluorides, is particularly octahedral structure they will follow. Okay, so must think what kind of hexades they are forming. Now what you have to compare that what is the stability of these halides. Okay, if particularly held stability in terms of halogen you are asking, so always stability moves in this manner, because atomic size goes on increasing, that's why bond association becomes easy. So the stability is in this order in case of the halogens. But if you talk about the elements particularly, if you are comparing the halides of two particular elements, at that time we need to discuss about their stability and their geometry first thing. So EX6 have sp3 dihydrogen, octahedral, stable state, only with the fluorides and gaseous in nature. But if you go for the EX4 particularly, okay, like SF4, okay, so it is particularly gaseous. Selenium fluoride is a liquid, while if you go for tellurium hexafluoride, that is particularly solid in nature. If you go for the hybridization, they are showing sp3d hybridization, and structure is bipyramidal. Bipyramidal. Okay, bi mean two for instant. Two pyramids will form bipyramidal structure. These possess particularly. Okay. Now about the dihalides. So dihalides only first thing chlorides and bromides are possible, which is due to exception not possible with the selenium. Okay, however, these things are possible with the dihalogens particularly. Okay, however, they are not much stable and their hybridization remain sp3 and structure will be tetrahedral. I am again repeating, dihalides only possible with the chlorine and bromine and not with the selenium. With the sulfur, tellurium, they are possible. Okay. Now, if you go for the monohalides also can exist in this particularly, but as a dimer, mean to say like S2Cl2, S2Br2, Se2Cl2, Se2Br2. Okay, these forms dimers because in single form they are not possible, monohalides particularly, and they also can show disproportionation. The good property disproportionation they can exhibit, like H2Cl2 frequently get converted into SCl4, mean to say hexafluorides particularly, okay, releasing the sulfur. Okay, so that's how all particularly monohalides which are dimer particularly existing can show disproportionate reactions particularly. So I am summarizing you first thing, what you have to tell that what kind of halides they are forming, and you have to compare those all halides, that what is their hybridization particularly, what is the geometry particularly in these forms, okay, and their stability order, mean to say their existence, physical states, how it is differentiate between all different characterization. Okay, so this is our today chemical properties has completed. I am again repeating what we have done. Chemical properties, oxidation state. Second we discuss is anomalous character of a oxygen element. Third thing we discussed is about reaction with hydrogen, then reaction with oxygen, then reaction with halogen. So these things are compromising all the chemical properties of 16th. We have already discussed in the last two lectures. So now, today's homework is to first thing is read up to the page number is actually in NCERT is 183. Okay, and there is a in text question, solve them in rough notebook. Okay. Third thing, you will make your notes in fair notebook. Okay, thank you.